This video is all about the sum of trigonometric functions and how we can rewrite them as a single trigonometric function to help us to solve equations or to find maximum and minimum points and when they occur. So from year 12, we're hopefully very used to the sine graph, what it looks like. We're used to the roots at when x is 0, 180, 360, and so on. We're used to its maximum being 1 when x is 90, and we're used to its minimum being -1 when x is 270. And we can do transformations of that graph as well. For example, if I was to draw the graph of 2 sine x, that's going to be exactly the same, but twice as big in the y direction. So it would look something like this, where we would have the same roots. It would have a maximum of 2 now when x is 90, and a minimum of -2 when x is 270. Similarly, we are used to the graph of cos x. It has roots at 90 and 270. It has a maximum of 1 when x is either 0 or 360. And it has a minimum of -1 when x is 180. And similarly, we could do transformations of this if I wanted to. For example, if I did the graph of cos x plus 2, that's just going to move this whole graph up 2 squares in the y direction. So it would look something like this. And again, you could work out the maximum coordinates or the minimum coordinates from that. But this video is about when we have something that looks like this. If I have the graph of 2 sine x plus 3 cos x, so I've got the sum of 2 trigonometric functions. It's not as easy now for me to know what's its maximum point, or what's its minimum point, or what are the roots. It's not quite as obvious for me to figure this out. You might think that the maximum is just going to be 2 plus 3 is 5, but you can see that that is clearly not the case, because they will not have the maximum. Sine x and cos x do not have maximums at the same x value. So it's not as simple as that. So how do we find the coordinates of this point? Well, we're going to do so by rewriting the sum of these 2 trigonometric functions as one single trigonometric function. I'm going to rewrite it in the form of r sine x plus a. And the reason for that is, hopefully you can see that this blue line is like a transformation of the regular sine graph. You know, the regular sine graph does look like this. And you can see that the blue line has basically been stretched by a scale factor of r in the y direction, and then it's been translated by -a in the x direction. The question is, what is the r and what is the a? Let's figure those out. So I want to write y equals 2 sine x plus 3 cos x in the form of y equals r sine x plus a, where r is a positive number and a is between 0 and 90. So basically I need to figure out what r and a are going to be. Well, to do this, let's think back to what we know about this sine x plus a. In the previous video, we saw these formulae. So notice here I have got a sine x plus a. So I'm going to use this formula with the a being the x and the b being the a. So let me write that out. So sine of x plus a would be equal to sine x cos a plus cos x sine a. So that's me just substituting x plus a into the addition formula. And notice that we are timesing this by r at the front. So timesing by r there, timesing by r there, timesing by r there. Right, let's compare this to the original question, which was 2 sine x plus 3 cos x. Right, I can see I've got a sine x here and a sine x here. So for these to be the same, my r cos a would have to equal 2. Similarly, I've got a cos x here and a cos x here. So for these to be the same, my r sine a would have to equal 3. And now basically I've got simultaneous equations to work out r and a. Bit awkward simultaneous equations. These are probably ones that you've not really seen before. So I'll show you the method we're going to use. If I divide both sides by r, I've now got my trigonometric ratio. So cos a is 2 over r. Now remember that cos is the adjacent divided by the hypotenuse, and sine is the opposite divided by the hypotenuse. So I'm imagining this as being a little right-angled triangle where this is my angle A, the adjacent side is 2, the opposite side is 3, and my hypotenuse is r. This is going to allow me to work out r really easily, because I can do a little bit of Pythagoras here. I can say that r squared is going to equal 2 squared plus 3 squared. So r squared equals 13. So r is the square root of 13. I can calculate the a, because I can do, here's my a, this is the opposite, this is the adjacent, so I could say that tan a is the opposite divided by the adjacent. So a is going to equal tan inverse of 3 over 2, which is 56.3 degrees to 1 decimal place. So what we have just found then is that if the r is root 13, and if the a is 56.3, then this is the same thing as this. So I can rewrite this expression in this form. So I can rewrite this 2 sine x plus 3 cos x as a single trigonometric function as root 13 sine x plus 56.3. This is the same thing as this. It looks more complicated because we've got a square root and we've got a 56.3 inside the brackets. So it looks slightly more complicated, but crucially, actually, it's much simpler because we have just got a single trigonometric function sine. rather than two different trigonometric functions. And that's useful because I know how the sine function behaves. So I can now use this answer to help me to find out the maximum value of this graph and the minimum positive value of x for which this occurs, basically the coordinates of the maximum point. Right, I know that the biggest that sine can be is 1. So if I times that by the root 13, I get root 13. So the maximum coordinate of y for this graph is root 13. And this is going to take place when does the sine graph have a maximum? It's when this bit on the inside here equals 90. A sine graph is a maximum when we do sine 90. So that x plus 56.3 has to equal 90 degrees. Therefore, the x will be 33.7 degrees. So my coordinate of the maximum point of this graph is 33.7 is the x coordinate and root 13 is the y coordinate. Let's just double check that. Here's my graph, and you can see, here's my 33.7 degrees, that's my x coordinate, and this is the root 13, the y coordinate. What about the minimum coordinates? How would I work out this? Let's go back to my equation. So, the minimum. Well, I know that the smallest, let me just get rid of this, the smallest that the sine graph can be, the smallest that this can be is -1. So when I times that by root 13, I get minus root 13. When does the sine graph equal its minimum point? Well, it's when this bit on the inside here equals 270. Sine 270 is -1. So therefore, x plus 56.3 equals 270. So if we subtract the 56.3 from 270, we get the 213.7. So the coordinates of our minimum point are like that, which you can see is correct down there. So key things about this video. It's using the trigonometric identities, the addition formulae, to rewrite the sum of trigonometric functions as a single trigonometric function. And we can then use what we know about the sine and cos graphs to figure out the maximum and minimum points.